Guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 540, single element in a sorted array. So you are given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. Return that single element that appears only once. Okay, so if the array is like this, okay, then I can tell you the answer is 2 because 1 appears twice, 3 appears twice, 4 appears twice, 8 appears twice, right? So 2 is the only element that appears once, and it is going to be my answer. And they have given that there will be only one element that appears only once, so it is guaranteed. Okay, now here 3 is appearing twice, 7 is appearing twice, 11 is appearing twice. Meanwhile 10 is appearing once, so 10 going to be my answer. Can you understand this? Okay, fine. So what is going to be the brute force approach initially? So the approach that comes directly into our mind is I will be taking a pointer and sending towards here, and I'll be checking whether it is in that array or not. Simple, yes. So I'll be placing in this one. Now I'll be going across all other elements and checking whether this one is present or not. So whether this one is present, yes. So it cannot be a single element, right? Okay, now go to the next element. So the next element is this one. Now whether this one is present here, yes, it is present before it. Okay, now again go to this 2. Whether 2 is present here, go to all the values and check it. So there is no 2, right? There is no 2. So at this point I can tell that 2 is going to be the single element. Okay, fine. Now tell me what is the time complexity. It is going to be O of n square, and space complexity going to be O of 1. Okay, and if you see this approach, you can understand whenever we are trying to find any elements. For example, let me take any other values, 1, 1, 2, 2, 3, 3, and 4. Okay, now if I go and find any values, so first I will be taking this one, whether this one is present in anywhere except itself. Okay, so I'll be starting from where? I'll be starting from here. Yes, 1 is present. Okay, now go to the next value. So I'll be taking this pointer and moving here and checking without going to this particular index. I'll be checking whether all index is not equal to this one. No, unfortunately starting itself it is 1, so I cannot tell that 1 is a single element. So go to the next element. Okay, go to the next element. Okay, 2. Now I'll be checking from the front. Okay, whether 2 and 1 are same, no. Whether 1 and 2 are same, no. Whether 2 and you cannot go to this element. Okay, so skip here and go here. Whether 2 and 2 are same, yes. So I cannot tell that it is a valid single element, right? So it is like I'll be taking one element and traversing every element in the array and checking whether it is there or not. So it is not necessary, right? Because this array is sorted, is in sorted order. So definitely if any particular element have its own value in the array, it should be either in the previous or in the next. Can I understand this? Okay, so my final approach will be like, let me take this array. Okay, so now my second approach is I'll be traversing every element. So first I'll be traversing to this one, whether this one has its previous value as 1, no. Whether this one has next value as 1, yes. So go to the next element. So next element is 1. Whether this one has previous element as 1, yes. Whether this element has next element as 2, no. But it has previous element as 1, right? So it cannot be the single element. Now 2. Whether this 2 has previous element as 2, no. Next element 2, no. So here I can tell you that this 2 is going to be the single element. So it is going to be the output. Can you understand this? Because the array is sorted, then why I have to go along all the elements? Instead, I will be only going and checking whether it is equal to any one of the neighbors. If it is equal to any one of the neighbors, then I can tell you that it is not going to be the answer. Yes. So this is going to be your second approach. And tell me what is the time complexity. It will be O of n, and space complexity it will be O of 1. Okay, fine. Now whether we can still optimize it, because this array is in a sorted order. Whenever there's a sorted keyword, then we want to search for a binary search approach, right? So Now let us find, by using this binary search approach, we can solve this problem or not. Okay, let me take an example. Yes, so this is going to be the first example I want to demonstrate with. So for the binary search approach, we want to start from 2 pointers, right? So one pointer will be u, sorry, L, the lower limit, and another pointer will be u, the upper limit. If you don't know about the binary search, okay, then go and watch my introduction video on binary search. I'll be giving that link in the description. Okay, from there you can understand what is meant by binary search and continue this video. Fine. Now what is the midpoint going to be? Midpoint going to be 8 divided by 2, which is equal to 4. So this is going to be the midpoint. Fine. Now check whether this 3 is a single element first. Okay, which means whether this 3's previous element is 3. Yes. So this 3 cannot be the single element. Can understand this? If its neighbor value is equal to the particular index value, then there itself I can tell you that what, that particular value is not a single value. Okay, now in binary search we want to either go to the right side or we want to go to the left side. That thing we want to decide, right? That thing we want to decide. If for any particular condition, if we can decide that particular logic, then we can do this using the binary search, right? Now by viewing this, I can tell you that we want to move left side because 2 is the single element and we want to move to the left side. But in logic, how we are going to do? See this carefully. Now where its duplicate is present, the mid's duplicate. So this is mid, right? So mid's duplicate is present in previous value. It's in previous value. So mid duplicate is in previous value, which means index -1. Okay, and also the mid value is what? 4. 4 means it is even. Okay, if it is even, that means in front of it there should be even number of elements. See here, 1 2 3 4. So even number of elements. Can you understand this? If in front of me there is even number of elements and my pair is also in front of me, then I can tell you that there should be a single element. So now where should I go? Either to the left side or to the right side. I want to go towards the left side. So I want to take only these elements as my part, right? So what should I do? I will be making my upper limit to mid -1. Okay, fine. Now what is the mid value? Mid value is 4 divided by 2, which is equal to, 3 divided by 2, which is equal to 1. So this is going to be mid. Okay, again whether it is a single element. No, its duplicate is in front. So now what is the case? The duplicate is present in my previous, which means index -1, and my current index is what? Current index is odd 1, right? Which means in front of me there should be a odd number of values, which means there may be any number of pairs. Will be making even, plus my own pair make it odd. So I can tell you that going towards left side is unnecessary. I will be going towards the right side, which means I will be making my L pointer to mid +1. Hope you understand this. Yes. Now again, what is going to be the mid, which is 1 by 2, which is equal to, mid going to be 2 plus 3 minus 2 divided by 2, which is equal to 2 plus 0, which is equal to 2. So mid is equal to 2, right? So go to 2. Okay, now this is going to be my mid. Now whether it is a single element, yes, because its previous element is not equal to 2 and its next element is also not equal to 2, which means I can directly tell you that it is going to be my single element. Can you understand this? Yes. So I'll be returning 2 as my output. Fine. Okay. We have these cases, which means if my current element is equal to the previous element, then what to do for even index and odd index? Okay, let us take another example so that you can understand what we should do if my duplicate is in my next index. Okay, so let me take this example. Listen this carefully. So here my L pointer, here my U pointer. What is going to be mid? 6 by 2 is equal to 3. So this is going to be mid. Okay. Now whether this mid is a single element? No. It has a duplicate value in its right side, which means index +1. So it is having a duplicate value next to it, which is index plus 1, and also its own index is what? Odd. Okay, from here what I can tell you that if it is an odd value, then in front of it also there will be odd number of values. Okay, in front of it there are odd number of values. That's fine, that's clearly fine. But its own pair is in its right side. That means in its left side there should be a single element. So at this point, what should I do? I'll be going towards the left side. So u is equal to mid to minus 1. So make my upper limit to mid to minus 1. Okay. So similarly here also, here what will we be doing? If the previous element is same, okay, and also it is even, where should I go? I'll be making my u to mid to minus 1. Here I will be making L to mid to plus 1. Okay. Similarly here, after I'll be making this as my mid, right? This particular value as my mid. Okay. Now if this is a mid, then I want to check whether its duplicate is where? Its duplicate is in previous. Okay, which means index minus 1, and also it is a odd value. Then where should I move? I should be moving my L to mid to plus 1, as we saw already. So this condition. Okay. So this will be going to where? Mid to plus 1 here. So this is going to be the mid now. This 2 is going to be the mid now. Now whether this mid is a single element, yes. So I'll be returning 2 as my output. Okay. Here I want to tell you some important thing. At first itself, it's better to test the corners. For example, in some cases, the test case will be like 1, 2, 2, 3, 3. Here this 1 is the answer, right? This 1 is going to be the answer. So at first itself, you want to check whether the 0th element or the last element is a single element or not by comparing its before and the next element, so that we don't want to just go for a solution like whether we want to take the first element in my binary search or not. In some cases like if this is the mid, then I want to check whether mid there is a existence of mid to minus 1 or mid to plus 1 or not, right? To exclude those conditions, first of all check for 0th index is a single element or the n minus 1th index is a single element or not. Then proceed with L is equal to 1 and u is equal to last index minus 1. Can you understand this? Why I am doing this? Because you want to get rid of the conditions. Okay, fine. Now tell me, what is the time complexity? Time complexity will be O of log n. Okay. Now what is space complexity? It is O of 1. That's it. Fine. Let us see the code so that it will be more clear. So see here, this is going to be the code. I prefer the Java code. If you want C++ or Python code, you may go and search in the description. So see here, first of all, I am taking the length of the array. Now I am checking whether the length is equal to 1 or else the 0th index and the first index are not equal. Then I want to return what? The 0th index element. Okay. Now I want to check whether the last index element is not equal to the last index previous element. If it is so, I will be returning last index as a single element. This is what I told you in the drawing explanation at last. And then where should it start? L is equal to 1 and u is equal to n minus 2. Why I am doing like this is, it is so simple. If the mid is at a particular index like 0th index or the last index, then we want to add some more conditions like for checking whether it has a previous index or it has a next index or not. To avoid those conditions, those clumsy conditions, I am going with this easy approach. Okay. Now while L is less than or equal to u, then I will be going and checking. So unfortunately for this problem there will be exactly one solution. So always this return value will be executed. Note that. Okay. Now mid is equal to L plus u minus L divided by 2. Now I want to check whether my mid is not equal to its previous value and also its next value. If it is so, I'll be returning it as a single element. L if what are the other possibility I have? L if my mid is equal to my next value. So here you may also put like equal to my next value. Okay. If it is so, what should I do? if it is if the my value is equal to the next value, then I have two cases. My mid value is even, or it is a or. If it is a even, then where should I go? L is equal to mid plus 1. Else where should I go? U is equal to mid minus 1. Here we have saw in the drawing explanation, right? Here the next. Yes, if it is equal to the next, okay, then in my odd case I want to move L is equal to U is equal to mid minus 1 in my odd case. Then definitely in even case L is equal to mid plus 1. Hope you understand this. Now else means if my mid value is equal to the previous value, then what should I do? I'll be checking again for the even and odd. If it is a even, then I want to move my upper limit to mid minus 1, else I want to move my lower limit to mid plus 1. After that, there's a dummy return for minus 1. That's it. So let me submit it. And if you want a brute force approach, you just do the brute force approach, because it is so simple, right? So I have totally of 3 approaches. So whereas the binary search approach is quite difficult to come up with, so that if you understand the binary search applications clearly, you can come up with that also. Fine. So it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. And if you have any doubts, you can comment below. I'll be commenting the answers. Okay. Thank you.